Hello, everyone. A very good afternoon. Dear authors and invited guests, welcome to a technical session 10D. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, held in Bangkok, Thailand. The ninth edition of this conference is being held in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held through Zoom on today and tomorrow on the 5th and 6th of April. I hope you will enjoy the knowledgeable and interactive sessions through the day. So, in this session, we will have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is also another request to everyone that please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat. So before we start the session, I'd like to introduce you all to our session chair. Dr. Rupali Mahajan ma'am, she's an assistant professor and head of department of CSE in Vishwakarma Institute of Information Technology. She's highly accomplished professional with a strong background in computer science and engineering. She's contributed significantly to the field, holding 18 patents. Welcome to the session, ma'am.
Thank you so much, ma'am. Thank you.
Thank you. Moving on next, we like to start with the presentations. I'd like to call Ms. Kartika ma'am for her paper titled A Bio-Inspired Framework for Lung Cancer Classification Using Fast Flash Hadmor Transform and Gene Expression Data. Ma'am, can you please start with your presentation? I believe ma'am is not in the meeting, so meanwhile, we can move on to the next presenter. I'd like to call Mr. Yash Suthar for his paper titled AI and Monkeypox, Revolutionizing Early Detection and Diagnosis. So can you start with the presentation? Moving on next, I'd like to call Sir for his paper titled AI for Academic Performance Prediction, a Review. Sir, are you in the meeting? Can you start the presentation? Sir, are you in the meeting?
Good afternoon. My name is Jose Luis Mastarreno Ponce, and it's an honor for me to present our research title, Artificial Intelligence for Academic Performance Prediction and Review. Artificial intelligence has become a fundamental tool in higher education and the improvement of academic performance. This study conducts a systematic review of the literature on the application of artificial intelligence to predict academic performance in virtual education using the PRISMA methodology. A significant aspect of this research is the ability of the artificial intelligence to process large volumes of data and generate accurate predictions. A methodology process was followed in accordance with the PRISMA guidelines. Phase 1, identification of research question. 3 questions were formulated to carry out this review. Question 1, what artificial intelligence techniques had been used to predict academic performance in virtual higher education environments. Question 2. What variables influence the prediction of academic performance in virtual higher education environments? Question 3. What data sources are used as datasets to predict students' academic performance in virtual higher education environments? Phase 2, search strategy. An exhaustive search was carried out in different academic databases with Scopus, Sensei Direct, Springer Link, IEEE, Explorer, Web of Science. Phase 3, designs of the search strategy. To execute the search process, key terms were established and a search string was formulated for each question. In phase 4, study selection criteria. The exclusion and inclusion criteria were inclusion, lenguaje Spanish or English, field of study, higher education, tipo de study, research predicting performance, outcomes or risks of student failure, and exclusion, context limited to a school or college, and systematic literature review. The study selection process began with the identification of 762 studies. Due to the specialization in higher education, 233 studies were excluded. Titles, abstracts, and keywords were analyzed, resulting in the exclusion of 73 studies due to the lack of relevance. Applying the selection criteria, 120 studies were discarded, leaving 41 studies for analysis. Artificial intelligence techniques used in interpreting academic performance. Among these techniques, machine learning algorithm stand you, with random forest being the most used, representing representing 25%. Is followed by support vector machine with 18%, decision tree and logistic regression with 14%, naive Bayes with 12%, Canary neighbor with 11%, artificial neuronal network with 7%, and long short-term memory with 5%, and other techniques represent a smaller percentage. Variables that influence the prediction of academic performance in virtual environments. The analysis reveals several categories that significantly influence academic results. The most significant factor is academic performance at 32%. Learning behavior follow is the second most influential variable at 29%. Demographic variables contributed 23%, while learning actividades for 8%. Other contributing factors include emotional variables at 3%, and predictor variables at 2%. Dataset used in predict models. The analysis shows that models have been applied across diverse digital environments, with 41% on educational platforms and 29% on MOOCs and LMS. Dataset often include tools like Moodle and Blackboard, along with multilingual academic repositories containing records in English, Spanish, Portuguese, and Chinese. Sample size vary widely from 35 students to over 122,000 records. Implementation of artificial intelligence models in educational environments. Integrating models into education requires a technical and ethical approach. Phase 1, diagnosis and data preparation. Conduct educational needs mapping, identify what needs to be predict, academic performance, risk of dropping out, or difficulties in certain subjects. Combine demographic data with digital interaction in hybrid classes and emotion in in-person classes. Phase 2, develop an ethical and scalable model, protect privacy with anonymous data, establish multidisciplinary ethics commits, check if the intelligence in artificial intelligence has bias. Select architectures based on data characteristics, structured time series, and small samples. Uh, Phase 3, iterative deployment and continuous training. Test the model in real-life situation. Update the
Excuse
model
me, sir.
every semester.
Sorry to interrupt, but around 9 minutes are over. Can you please wrap up?
The systematic review of the application of artificial intelligence in predicting academic performance in virtual environments has revealed significant with index that warrant detailed analysis. Previous academic performance is the most influential variable, followed by learning behaviors and demographic, highlighting a multidimensional approach to prediction. Unlike studios focus only on demographic variables, this review highlights the impact of contextual and emotional factors. Eh, Data quality and variety are key to predict models. A study with tier 6 case and logistic regression achieved good results in a limited context, while another with 29,192 fights a gradient box matching and nearest neighbors. Models achieved in one a score of 98%. This highlights the impact of datasets since on model performance. Comparative analysis show the natural network outperform traditional methods, eh, especially with complex data. Key factors like previous academic performance, learning behavior, and demographic are crucial in predicting academic success. The quality and variety of dataset used in predicting models are vital for accuracy. Results depend on the size and type of data, from small samples to larger datasets from MOOCs and LMS platforms. To improve prediction in virtual environments, it's essential to use comprehensive datasets that reflect student behavior accurately. Thank you.
Thank you for your presentation, sir. Ma'am, any questions?
Yes, wonderful presentation, Jose. I have actually one question. Why is AI considered a better approach compared to traditional statistical methods?
Yes, this review identified several notable limitations, including variable and methodological approach in quality across analysis study. which complicate the generation of findings. Additionally, many datasets fail to adequately represent the diversity of educational contexts, limiting the applicability of predict models. Future research should therefore broaden its scope by incorporating data from diverse regions and educational settings.
Okay. And in your project, what limitations are acknowledged in your studies?
Furthermore, developing models that systematically integrate emotional and contextual variables is recommended to enhance the order starting of academic performance in virtual environments. And such an approach aims to overcome the limitation inherent in current unidimensional models, providing empirical evidence to support the designs of personalized education interventions.
Okay. Thank you so much.
Thank you.
Nice. You can
Thank you
continue
for
with the next session, ma'am. Next.
yes, yes. Thank you for your presentation, sir. Next, we like to call Mr. Shifty Ishmael for his paper titled Bangla Sign Language Detection Using Deep Learning. So, can you please start with your presentation?
I am trying to share, but I can.
Try again. I stopped sharing.
Thank you. Is my slide visible?
Yes.
Thank you. Good morning, good afternoon, everyone. My name is Shifty Mohammad Ishmael, and today I will be presenting our research on Bangla Sign Language detection using deep learning. This research was conducted by Shahrin Inteshaikat, Borsha Shah, myself, Ryan Rahman, and Muhammad Nur Hudasa. This is the outline of our slide, the introduction, related work, methodology, model training, result, and the conclusion. Now I'm going to start with the introduction. Communication is a fundamental right, but over 2.4 million people in Bangladesh who rely on Bangla Sign Language, aka BDSL, face significant barriers. Existing technological solutions often lack comprehensive coverage of BDSL sign, which have high error rates or maybe slow. Our goal is to bridge this communication gap by developing a system that can accurately and efficiently translate BDSL into text or spoken Bangla. Specifically, our objectives were to build a system that recognizes BDSL sign from video in real time, improve accuracy using object detection, develop a comprehensive data set, and address the challenges for classifying the signs. Now the related work. In the previous research of BDSL recognition using models like Inception V3, ResNet, CNNs, and earlier YOLO versions, they had very good accuracy and showed promise, but often suffered from key limitations like many didn't cover Bangla minor letters or digits or many other. Our work aims to fill this gap by developing a system that recognizes a full set of BDSL alphabets and digits. The methodology. Our methodology involved compiling a data set, reprocessing it, training a model, and evaluating its process. We used the YOLO V10 model chosen for its efficiency and accuracy in object detection. We combined two data sets, KU-BDSL and BDSL 47, resulting in 48 classes covering all 44 letters and 10 digits. You may think that it calculates on 54 classes, but some hand languages were what it say similar, so we shrinked it down to 48 classes as they were similar. The dataset includes 500 around 500 700 images captured under diverse conditions. Pre-processing it. Pre-processing involved steps like auto orientation, resizing it, a contrast adjustment, etc. We also augmented the techniques like rotation grayscale conversions. Now to the model training. We trained the YOLO V10 model iteratively, starting with grayscale images, gave us a good baseline. Switching to RGB images improved the performance, which is in MAP 50 0.992. Finally, adding more images and retaining it, particularly focusing on balancing the data set using synthetic data and represented classes, which improve the result and bring it to 0.9924 in MAP 50. Now to the results. Our final model achieved a higher accuracy of MAP 50 of 0.99241. The training performance curve shows effective learning with good generalization and lower overfitting. When compared to mobile MobileNet V2 and faster NNN on our dataset, YOLO V10 provided the best accuracy. Validation tests showed correct classifications in most signs with improvements after data balancing. Real-world tests also demonstrated a higher confidence predictions of 10 above 95%. And now the conclusion. In conclusion, we have successfully developed a highly accurate system using YOLO V10 for detecting all Bangla alphabets and digits. A key feature in the inclusion of token generation, paving the way of future natural language processing integration to construct sentences. This work significantly advances the BDSL recognition technology, offering a practical tool to improve communication accessibility for the deaf and hard of hearing community in Bangladesh. Future work may involve expanding the data sets and user-friendly applications. This is the references for the papers, and thank you for the attention. Thank you.
Yes, excellent presentation. Uh, can this model optimized for deployment on edge devices like smartphones or Raspberry Pi?
We actually did it in the PC as the computers. We actually got, which is a good question. Thinking about implementing after like implementing in the PC. Then we might think of implementing in Raspberry Pi as we need it for mobility purposes.
Okay, that's great. And
Thank you.
can this deep learning model that originally trained on Bangla sign language be adapted to recognize sign language from other regional languages?
The sign languages, I think, was for only Bangla sign languages. I think it will have a little bit problem for other languages as it was not trained on those languages. But I think it has potentiality for other languages if we trained on it.
Okay. Okay. Thank you
Thank
so
you.
much. Yes. Okay.
Thank you for the presentation, sir. Moving on next, I'd like to call Mr. Gotipati Sai Prakash for the paper titled Bidirectional LSTMs for Efficient Indian Sign Language Clause Recognition. So please can you start with your presentation?
Yeah, I'm sharing my screen. Is my screen visible?
Yes, sir.
Okay. Uh, Good evening, everyone. I am G. Vaisya Prakash from Amrita University, and today I'm excited to present our research project titled Bidirectional LSTMs for Efficient Indian Sign Language Gloss Recognition. So, coming to table of contents, here is a quick overview of what I will be covering in this presentation, starting with our problem statement, followed by our objective, system architecture, deep learning models that we have used, the implementation steps, the key findings, and the limitations, and our conclusion in the futures. Coming to the introduction, in India, there are around 70 million users who are dumb and deaf, and they often have a communication gap between non-sign speaking users and them. Like as we knew, communication is a fundamental human need. However, individuals with these issues often face challenges in communicating effectively with others. Even though there are a traditional sign language interpreters are not always available, and most real-time systems are either expensive or inaccurate. So our motivation was to build an accurate and a real-time sign language recognition system using deep learning methods, and we currently focus on Indian Sign Language. So coming to our research objectives, the core objectives of our research were is to develop a real-time sign language recognition system and also to explore and compare deep learning models like CNN, LSTM, GRU, and BiLSTM, and 3D CNN. Also, we have used MediaPipe for efficient hand landmark extraction, which enhances our feature accuracy and model performance. Coming to the system architecture, our system follows a modular pipeline. It starts with data collection via webcam, followed by pre-processing using MediaPipe to extract 21 hand landmarks per frame. These landmarks are saved into NumPy arrays. As I later into the discussion, I will explain about the pre-processing. Currently focusing on system architecture. Here you can see, as they have been stored as NumPy arrays, this will be set into a train test split model and divide them into training accuracy and training split and testing split. And the data has been fed into different models as CNN, 3D CNN, as I have mentioned, and have been hyperparameterly tuned and set for real-time prediction. Now coming to the deep learning approaches that we have used CNN to extract the spatial features from the frames. We also use 3D CNN for modeling spatial and temporal features, LSTM for sequential recognition of hand movement, BiLSTM for sequential and temporal frames collection, and also maintain the long frame length features, GRU as a lightweight alternative to the LSTM. Among all of these models, what we have observed is BiLSTM stood out, which has the best performance comparing to the other things, which I'll be later conveying in results. So coming to the data set details, uh, what we did is like we have made a custom data set by referring to official Indian Sign Language website. And not only that, we have served through different websites to find a pre-populated data set, but there was a lot of ambiguity. To reduce it. What we have done is we went through this Indian Sign Language website and we have made our own data set based on the signs. So coming to the implementation details, focusing on the data pre-processing, like we have captured 30 videos for each sign and cropped the region of interest that we required. We have resized and labeled them accordingly. As coming from the video input, we have captured the landmarks using MediaPipe extraction. Then these landmarks are converted into NumPy arrays and we have normalized them. And the final data set here has been divided into training and testing sets before passing into the models. This is the pre-processing flow, basically. Uh, Now coming to the results that we have observed is like as we said, right, we tested each model's performance using accuracy and confusion matrices. BiLSTM achieved about 92% accuracy, significantly better than the rest of them. It also showed better generalization on unseen data compared to LSTM and GRU. The model was tested under real-time conditions with a good results. As what we found is even there was a good accuracy to some models, but it was not able to recognize the signs in real time. As how However, the BiLSTM did in real-time prediction better compared to other models. That's what I want to say. As BiLSTM did better because it has a feature extraction as it can be done in past features and future features. That's what we observed in this particular research. And the key findings, coming to the results part, these are the two graphs where over a set of epochs, training and validation accuracy has increased and training and validation loss have also been decreased for a certain set of epochs. Here we took around 50 epochs. These are the results you can see for the LSTM, BiLSTM, 3D CNN, DRU, and CNN. Even though there was a good accuracy in CNN, 3D CNN, but coming to the real prediction, it didn't perform as well as good as BiLSTM. So coming to the key findings and the limitations, as you know, BiLSTM gave the best results for this sequence learning, and also our inputs in Indian Sign Language, all our videos, there are no images, as most of the signs in India have been done using videos. So also the media pipe has improved our pre-processing and reduced noise. Coming to the limitations that we have encountered is mostly like the system's performance may also has depend on the lighting condition, and also there was a smaller data set that we went through, as we can go for a larger data set, but the model is that much suitable for a larger data set. So currently we worked on a smaller data set. And I just want to conclude that our system has successfully demonstrated a deep learning based approach, especially using the BiLSTM, and also can effectively recognize the Indian Sign Language in real time. And the media pipe enabled the fast and efficient data processing. Now coming to the future work, looking ahead, like we initially had a plan to expand our dataset with more complex and dynamic signs, and also build a fully bidirectional system for translation and production, like an app communicating for translation and production, like a full bidirectional system, and also incorporating the LLMs to better interrupt sign sequences in a semantic context. As of now, presently, like as of our future work, we have completed the communication system for translation and production. Now, just we are working on the larger data set. And thank you so much for your attention. And I'm happy to take any questions. Please.
Excellent presentation.
Yeah.
What type of what we can say challenges you have faced in your project?
Basically, the major challenge that we have faced was fetching the dataset. As coming to Indian Sign Language dataset compared to other datasets, most of the signs have been, I mean, the signs basically we took the words are done in videos. So gathering these many videos and like there was only one video available. So only with one video, we can't train a dataset. We need a sample set of video. So that was the major challenge. So that what we did is we saw that sign, and like there were four of us, we did the same sign 5 times, and also we took an expert help so that we get 30 samples of video of that particular sign. That's the main challenge as for us.
Okay. Okay. Thank you so much.
Thank you for the presentation, sir. Moving on next, I'd like to call sir for the paper titled Contextual Awareness in a Communication Architecture for Smart Manufacturing. Can you please start with your presentation?
Yes, just hang on. Share. I just want to confirm that you all can see my screen and you can hear me clearly.
Yeah, your screen is visible.
Awesome. Greetings all, and thank you for joining me for my presentation on contextual awareness in a communication architecture for smart manufacturing. My name is Gary Gerke, and I'll be taking us through this presentation of our research co-authored by Professor Kuriakos and Professor Vermaak. In this presentation, we'll be looking at the background of smart manufacturing and communication architectures, contextual awareness in smart manufacturing, a smart manufacturing case study, the results of the communication architecture and environment of smart manufacturing, and we'll discuss the advantages of using the communication architecture and looking at the future work of the study. Smart manufacturing units, or SMUs, are the embodiment of smart manufacturing by introducing discernible characteristics such as sustainability, cloud manufacturing, cybersecurity, contextual awareness, data analytics, and interoperability. These characteristics are realized through the enabling technologies. While the definition of these characteristics and enabling technologies are agreed upon by researchers, their level of implementation is diverse across many fields. Looking at the different types of architectures, architectures are generally split up into two major categories of hardware and software architectures, with these two categories being refined with many notable examples such as Harvard, RISC-V, domain design, and client-server architectures between the two major categories. These architectures also have their definition of creation well established, allowing for iterations and new architectures to be more easily created and compared. However, one aspect of architecture is not research is communication architectures. Whilst communication between networks, nodes, and machines is largely established through the use of protocols, the protocol alone is not extensive enough to classify as a communication architecture, such as hardware and software. Instead, additional aspects need to be taken into consideration, such as the flow of information and network level of responsibility, in order to fully realize about architecture in the field of communication. Within the study, we asked the research question of, can a communication architecture improve the production efficiency and bring about the intelligent decisions within machines to create smart manufacturing units? The study has thus developed a communication architecture with contextual awareness, information appropriateness, distribution, decentralization, and a network hierarchy as its core components for the communication architecture. Whilst the enabling technologies are these core components sharing similarities through the relationships of the smart manufacturing units. This study hopes to show the improvement in production efficiency with contextual awareness by integrating machines with a digital presence, self-awareness, and environmental awareness. This is done by structuring the machine communication packet with a machine type identification for self-awareness, assigning responsibility for production information, sharing and storage strategy, and creating a digital presence by establishing a dynamic network hierarchy for environmental awareness. This study makes use of a water bottling manufacturing plant as its case study. This water bottling plant has been recreated in MATLAB Solink to gauge its effectiveness for producing 300 and 500 milliliter water bottles to customer client orders. These bottles orders are collected at a cloud interface that is sent to a central server for ordering and scheduling onto their smart manufacturing units. The central server then sends these bottles out to each different SMU, where SMU1 is tasked with the identification of the fed-in bottle to the manufacturing line and filling the appropriate water amount. SM2 is responsible for capping the water bottle at their different heights of 300 and 500 milliliter water bottles, while SMU3 is required to package the water bottle to customer orders. While each SMU has the responsibility of production requirements, each layer within the smart manufacturing setup has their own responsibilities, defining one of the critical requirements of the communication architecture from its core components. Each network layer makes use of its own communication protocol, and within the presentation, we'll focus on the machine-to-machine communication. Each SMU communicates through a uniquely developed smart manufacturing communication protocol. This protocol, which draws inspiration from the IPv4, has been adapted to include machine-specific information that is accessible at the data link layer of the ISO stack and not at the application layer as traditionally done with machine-to-machine communication. This allows machines to act upon data at greater speeds and structure messages for effective communication, bringing down overall latency and overhead. The network interface of machines is simulated in conjunction with the production runs to visualize the flow of information between machines. Here we have direct access to the information being shared between machines to see a direct correlation between production changes and shared communication. We are also able to introduce events to change and disrupt the production runs and see how the system reacts. This allows us to benchmark the performance of the system when operating as a smart manufacturing line with a communication architecture and a traditional manufacturing setup. The communicated information allows SMUs to pinpoint computation requirements to identify connected machines in the network. This allows for two scenarios. Firstly, either the central server in this case can decide on the requirement of production requests and with the communication from all machines rather than one machine with a collection of attached machines to identify connected units on the manufacturing line. And the capabilities and deduce if production can be completed within the SMUs. Yeah. Secondly, the machines themselves can be programmed at the application layer to determine the available SMUs on the manufacturing line and decide if they themselves are able to complete the production task scheduled by the central server. This already allows SMUs to embed with contextual awareness by collecting information on attached machines in the manufacturing line and deducing the capabilities solely with the transfer of communication outside of data packets and the application layer, and rather within the header communicated packet and the data layer of the communication protocol. This communication approach will be able to reduce the latency and computational power, as communicated machine data does not need to be passed to application layers for processing. While this header information might be seen as an unnecessary overhead, the organization in streamlining the collected data can proceed as the source machine is communicated with a dedicated header and removing the constant repeating format of machine identification with constantly changing network environments. Machines operating within the fourth industrial revolution space and communicating on a network are required to be more pertinent with data they collect, store, and communicate, with this strict requirement of stored data per level being necessary for only that level. This is due to the massive amounts of data that is predicted to be produced along with the intelligent manufacturing line of the fourth industrial revolution. An example of this is the evaluation of the necessity for required sensor data to be stored at central servers. If per machine sensor data is not evaluated or is planned for future evaluation, then taxing overhead and storage space of this information would be put better elsewhere. SMUs of the fourth industrial revolution will exponentially create more computational resources than that of its predecessors. It is believed that smart machines are only realized with the use of smart operations and smart architectures. One case to highlight this within our study is while SMU1 is the first to receive a water bottle that can be fed out of order from constant orders or prioritized for customer orders, it is required to identify the type of water bottle, such as 300 or 500, as it is introduced into the system. This calculation is required to set the correct amount of water to be filled and validated on the completed water fill task. For this reason, SMU1 can be fitted with specialized sensors to determine the unique water bottle and levels. This does not automatically require all SMUs on the network to have similar sensors to complete this task. Instead, the identified bottle of SMU1 can be communicated and transmitted to other machines along the network to prepare them for their initial tasks and requirements. This communication more evenly distributes the computation and communication loads across the machines and takes full advantage of the SMU capabilities. While the combined use of the machine identification and information sharing tasks and calculations can not only be split amongst ideal machines, but the interactions between the calculations and the new changes in manufacturing line information can be automated. One method of achieving this is to compute the calculation, manufacturing, and network load experienced by each machine and compare that with each other to determine a live mapping of computational resources on each machine. Once this comparison takes place, it is possible to distribute the information across the network.
Excuse
Yes,
me, sir. Sorry to interrupt, but around 9 minutes, sir.
Yeah, that's almost that thing. Where the individual network nodes or machines can schedule appropriate tasks to less taxed machines, this computational collection, comparison, and distribution method of network loads across a system is a prime example of portraying the use of contextual awareness when using identification of information sharing is isolated. This per machine load can be automatically assigned to the machines with appropriate tasks assigned to less stressed machines, either from the production data of machines needs themselves or overlaying the requirements of the central server. We can see the additional information of the communication architecture that there's an apparent lag in production. However, this lag is instead a forecast as they are sent from SMU1 to SMU2 to allow preparation of machines for future and incoming orders. This research shows that with the SMUs being contextually aware and communicating around the communication architecture, there is benefits that is handled holistically. This holistic implementation is defined with the communication architecture to structure the flow of information as well as sharing information and assignment responsibility across the network. Whilst Industry 4.0 communication architectures allow for distributed system, the requirement of Industry 4.0 in smart manufacturing does not account for task scheduling, responsible calculation, or network hierarchy. It is rather seen that these requirements are best defined under an architecture due to their more specific nature, allowing SMEs to communicate in a contextually aware environment and allows for machines on the network to calculate manufacturing line capabilities. This distribution decentralization of information does, however, lead to the possibility of tasks and calculations being duplicated outside the requirement of redundancy. The further requirement of this distributed network avails smart manufacturing units underneath a communication architecture to schedule and manage tasks under a network hierarchy. While additional manufacturing data is being communicated in industrial forward network setup, additional overhead and latency are probable to be introduced within the setup if care is not adequately taken. However, when comparing the effectiveness of the incorporated architecture, specification of data storage and applicable data can be gauged to minimize the latency and overhead. Whilst not explicitly evaluated in this paper, the latency and overhead savings of the implementations are predicted and could be quantified against the expansion of the network, and this is seen as additional and future work within the study. We hope to continue this research with future iterations of the communication architecture, allowing for the inclusion of data feedback on production runs to the central server layers. Other iterations of the communication architecture can include more integrated and dependable production tasks. These tasks should allow for the greater characterization of the network hierarchy load distribution, further refining the input and output requirements on an affecting communication architecture core elements. We hope this presentation showed how the inclusion of a communication architecture can structure information in a smart manufacturing setup with great similarities, and we hope that the effectiveness of communication architecture in smart manufacturing units will one day impact the future of your lives. Thank you.
Excellent presentation, Gary. So, my question, as per my understanding from your presentation, assume a machine is operating at high temperature. Okay. And how can a context-aware system use this information to prevent system failure through intelligent communication?
So one aspect that we started to include with the communication protocol between machines was also looking at the internal communication between detached sensors and edge sensors. And we would follow a similar approach where we could collect that information in a structured layer to have that information available at a data link layer and not an application layer. So with that information being collected from a distributed sensor or edge sensor, you could automatically start including how your system and environment should react against that system. The specifics of warnings and shutdowns can still be programmed in the application layer, but the effective collection of that information and the speed at which that information is collected is at least defined within the communication architecture. So while it does make compensations for a broad category of data collection, the specific details is still characterized within how best to handle it in the communication architecture.
Okay. One more question. Can we add time and location context? Can we integrate time and location into real-time communication system
Yes, you can.
as
Again,
a future scope?
yeah.
As a future scope.
Yes, it is. Yeah, it is possible to add it as well. But what we would also, what we're advising on and looking into within our research is also the applicability of where that information is stored. While that information is pertinent during the production run, we would look at maybe increasing time spans of savings or a strategy of how to save production information to central servers at batch levels or lat levels rather than immediate real-time data, just to reduce network latency and overhead. And again, that also forms part of that whole strategy of data storage sharing between not only the intra layers, but also between all layers of the network system.
Oh, thank you so much. Yes, wonderful.
Thank you for the presentation, sir. Moving on next. I'd like to call Sir for his paper title, A Direct Dine, a Smart Solution for Seamless College Canteen Experience. So
Hi, am I audible?
yes, sir.
Yeah, okay, I'll share my screen 1 second. Is my screen visible? Hello.
Yes, sir.
Okay. So, good afternoon, everyone. My name is Alharith Hakim. I'm a final year computer science and engineering student at St. Gates College of Engineering, Kerala. And I'm excited to be here today at ICTIS 2025 to present our paper titled Direct Dine, Seamless College Canteen Experience. Now, this project was developed by my team of four, consisting of myself, Alan Ronnie Matthew, Alon John, and Christopher Thomas, under the guidance of our guide engineer, Jaren Sebastian. Now, together, the motivation for developing this application in the first place was to address a common yet overlooked issue, which is the inefficiencies in how college canteens operate. Now, moving on to the abstract, DirectDine is a mobile-based application which is designed to modernize how students place food orders in college canteens. Now, the current manual system which is used is inefficient, leading to long queues, order mix-ups, and delays. So our solution replaces this with a streamlined digital interface that helps students place and manage orders through their smartphones itself, which ultimately reduces human error and improves the experience for both the users, who are the students, and also the canteen staff. Now, for an introduction of our project, many colleges still rely on traditional, like I said, manual systems. Now, this will result again in crowded counters, miscommunication, and delays during peak footfall. So, DirectDine solves this problem by digitizing the entire process. Now, students can open and browse the menu of the college canteen and also place their orders through the app itself and get real-time updates. Now, this not only makes the experience hassle-free for students, but it also allows the canteen staff to handle orders more efficiently with less verbal communication or manual work. Now, for the features of DirectDine, some core features of DirectDine include a user login system, which has authentication, which allows for added security, which only allows students who have a valid college mail ID to log into our application. And then there is the live menu availability, which is updated by the staff in the canteen in real time. And then there is order tracking, which allows students to monitor their food status. And then there is the digital payments via UPI integration. And then additionally, there are the admin panels for canteen staff to view and manage incoming orders. And all of this is built with the goal of saving time, improving accuracy, and enhancing satisfaction for both ends of the system. Now, moving on to the methodology that we had followed, we started by identifying the common pain points through informal surveys and feedback from our peers and canteen workers. And then we used Figma for designing the UI and Flutter to develop the cross-platform mobile app. Now, Firebase was chosen as the backend due to its real-time data handling and ease of integration. Now, the architecture I have shown over here, it follows a clear separation of the layers, you can see. Now, the presentation layer, which handles the user interaction throughout the app, and then the domain layer controls the business logic and the validation part. And then the data layer manages the data flow from the Firebase database and authentication services. Now, moving on to the backend and front-end development. On the mobile front, Flutter provided us the ability to build a responsive, attractive, and consistent interfaces for both Android and iOS. And for the backend, we used Firebase database to store and sync orders and menu data. And then we also use Firebase authentication for managing user sessions. And then our admin functionalities are also handled through a dedicated mobile interface for staff, giving them real-time updates on pending and completed orders. Now, this ensures that both users and staff are always on the same page. Now, on a comparative study, we compared Direct Dine with other existing solutions for food delivery, like Zomato and Swiggy. Now, these apps might be feature rich, but they're not optimized for a campus environment where speed, cost effectiveness, and simplicity are key. So, our solution stands out because it's built specifically for in campus usage and it doesn't require GPS or delivery services. And it's lightweight, fast, and more accessible for students and canteen staff. It's tailored for a closed loop ecosystem like colleges. Now, on to the performance evaluation that we had found. We conducted a simulator trial within our campus, which involved around 2,000 students. And the feedback we had gotten showed that there was a 90% satisfaction rate, and the order errors were reduced by 40%, and the average wait time had also dropped. Now, additionally, staff had also reported that the operations were much smoother and there was less verbal confusion. And these numbers validate the efficiency and real-world applicability of our solution. Now, as shown in the table, DirectDine significantly outperforms the manual system across key metrics, and it processes more orders during peak hours, improving the overall efficiency. Now, it supports both cash and digital payments, adding flexibility for users. And also, like I mentioned just now, customer satisfaction had risen from 65 to 90%, thanks to smoother transactions and reduced wait times. And additionally, smart features like data analytics will be implemented, and real-time order tracking is available, and automated inventory is also integrated. Now, these are features that are entirely absent in a manual setup. Overall, this evaluation demonstrates how DirectDine delivers a more efficient, smart, and user-centric canteen experience. Now, in conclusion, I'd like to say that DirectDine offers a more smart, mobile-first approach to handling canteen operations. It's cost-effective, user-friendly, and built with scalability in mind. And for the future, we plan to integrate AI-based demand prediction, helping the kitchen prepare quantities based on previous trends, and add multi-language support to make it more inclusive, enable nutritional tagging for health-conscious users, and also it's used to other campus services like library queues or stationary purposes. Now, these are the references that I had used. And in a nutshell, I'd like to say that DirectDine transforms the chaotic college canteen experience into a much smoother, smarter, more digital one using just a single mobile app. So thank you so much for your attention, and I'd be happy to answer any questions.
Nice presentation and very useful project
Ah,
also. So
thank you.
I just wanted to ask you, how can the system dynamically manage peak hours and reduce the waiting time?
So, as I had explained, we have been using Firebase as the not exactly backend, but it's the database we had used, database service that we had used. And Firebase is known for its easily integratable services, and also it is a much more real-time, it has much more real-time applications. So the reason why I'd used Firebase is purely because of that. So it can, as compared to other database services, it can fetch data, even though it's a cloud application, it can fetch data much faster and also send data from the user side to the backend very quick. So that's how it easily reduces.
Okay. Okay. So just a suggestion, as a future scope or as a what we can say enhancement for your project, uh, can your app support students with visual impairments or other disabilities? You can add these points if possible.
Okay, yeah. So language impairment was an issue. So yeah, we'll definitely add this as well.
Visual impairments, blind
Yeah, accessibility. Yes, sure. We'll add that.
accessibility. Okay. Thank you so much.
Thank you.
Thank you for the presentation, sir. Um, Now I'd like to call sir for the paper titled Effective LLM-based Diverse Distractor Generation for Multi-Choice Questions. Please can you start with your presentation?
Can I share?
Yeah, you can share the screen.
Not audible.
Our contribution, we propose a new solution based on defined large disjoint with diverse beam set to automate instructor generation. We confirm that diverse beam set is a more appropriate encoding strategy for diverse instructor generation. Related work. There are many works for instructor generation. Presented on in 2022 proposed defined model and achieved Fluent score of 37. Zooming on in 2020 proposed BDG models and achieved Fluent score of 39. Upper Engine on in 2020 proposed GPT-2 and achieved Fluent score of 60. In this work, we only consider DeFi and BDG models, and we left out GPT-2 due to their low ROCL score reported in the origin paper. Methodology. We define the task of instructor generation as follows. Given a context C, a question Q, and a correct answer A, we need to generate three distinct instructors called D1, D2, and D3 that meet the following requirements. They may be a word, short phrase, complete sentence, or multiple sentences. They must be incorrect answers to the question Q when given the context C. They must be a plausible answers to the question Q, meaning someone without a full understanding of the context or question won't be able to tell if the instructor is the correct answer or not. Our most model is defined large disjoint. It should be noted that defined based disjoint is also reported in this paper. However, they don't discuss the benefits of using diverse beam set for instructor generation. So we propose defined large disjoint model. For the train architecture, the input is forwarded through the defined encoder and forwarded through the defined decoder with teacher forcing for each of the ground truth instructor. We compute the cross entropy loss for the three ground truth instructor, and we compute the minimum of the three cross entropy loss. The result is minimized for training. For prediction, the reverse beam set is used to predict three different instructors for the same input. Experiment. There are many versions of the RAID dataset. Version 0 is uploaded on Hugging Face. Version 1 and version 2 is processed by ground BDG models and trained on version 2 of the RAID dataset. However, in this version, there are many questions that don't have on three instructors, so it makes it difficult for us to train some of the models from this paper. So we construct another version of the RAID dataset called version 3, so that the sample IDs in the train validate test set is similar to version 2, and each of the questions will have on three instructors. We used version 3 for our experiment. And here is the statistics of the dataset. For evaluation metrics, we use blue, ROCL, and Meteor. We did not define as the similarity between the generated instructor and the downdraft instructor. Higher DI score will indicate more similarity between the generated instructor and the downdraft instructor, thus indicate that the models perform better. We did not DD and the similarity between the generated instructor themselves, where higher DD score indicates that the models generate very similar instructors to each other. So we want lower DD score for more diversity. For the models, we consider device small, device space, and device large proposed in this paper. We consider device-based disjoint proposed in this paper and device large disjoints proposed in our paper. And we also consider BDG models in June's paper. We downloaded this model directly from the GitHub repository. In the first experiment, we compared the DI score between different models. Defined large disjoint performs better than other models in 2, 1, 2, 3, and 4, and ROCL score. In Meteor score, defined large disjoint perform better and the first generated instructor. In the second experiment, We compared defined large disjoint models when the diversity parameter of divergence is different. Lower diversity, in this case, we make the model perform better as indicated by higher DI score. However, if we reduce the diversity as indicated by the higher DD score, conversely, higher diversity parameter makes the model perform worse as indicated by the lower DI score. However, the model generates more diverse destructor as indicated by the lower DD score. In the third experiment, we compare diverse pipset with other decoding strategy. Diverse pipset performs better than top-K sampling and contrastation. When comparing with pipset, diverse pipset doesn't generate as good destructors as pipset. However, it generates more diverse destructors as indicated by lower DD score. When comparing with multinomial sampling, even though diverse pipset doesn't generate as diverse detectors as multinomial sampling, as indicated by higher DD score, it generates very good detectors as indicated by higher DI score. So in conclusion, we suggested define large disjoint model to enhance the performance of automatic detector generation. We clarify the role of diverse pipset in creating more diverse detectors for multiple choice questions. We evaluated various large language model-based diverse detector generation from different perspectives. Thank you for listening.
Nice presentation. No questions from my side.
Yeah, thank you for
Thank you.
listening.
Yes, sir. Thank you for your presentation, sir. Moving on next, I'd like to call Vyashani ma'am for the paper titled Evaluating YOLO Model for Detecting Crowds in Sparse Regions. Ma'am, can you please start with your presentation?
Yes, very good afternoon. Give me a minute, I will share the screen.
Okay.
Okay, very good afternoon. Thank you for joining me today. So my name is Vaishnavi. Currently, I am pursuing my MTech degree in Vignan University. So today I am going to present our paper titled Evaluating the YOLO Models for Detecting the Crowd in the Sparse Regions. So firstly, we focused on the places where we have focused on the places where people are not that much crowded. So these are what we call it as a sparse region. In such areas, it is not always easy to detect the people correctly. So some people may standing alone or some people may far away from the camera, and it will make the detection harder. So our main aim is to find out which version of the YOLO is fast and a powerful object detection, and which version is the best at finding the people in these kinds of situations. And we have tested different versions of YOLO, that is YOLO V5, V7, V8, V9, and even the latest version V11. And we have used same kind of data for all these models, and we looked at how many people each model could correctly find out. So next, these are the literature survey that I have surveyed. So these are the research gaps. So some few methods from the literature that have not addressed the challenges of counting the people, especially in the closed areas. So current methods find it hard to count them, especially when there are many people or occluded by each other. So the method can work well in one data set but fail to work in another data set. So when people are very small in image and blocked by other, current methods are failed to detect and count them properly. So different weather conditions like bright sunlight, shadows, rain, fog can make it difficult for the existing models to count and detect them. So most of the datasets only cover the few types of crowds. So models don't perform well in new situations also. So the problem statement, the main problem we are looking at is how to detect and count the people when they are specially spreaded out and not in the tightly packed crowd areas. This is difficult. Sometimes the people are blocked by others also. So the camera angle, the people can appear small and far away in the image. Some older so some existing methods, including the latest versions YOLO, are not accurate enough. So, even though the newer version models are being fast and good at object detection, we still don't know the which version works best for the sparse crowd regions. So, in our study, we have tested different models and using two different data sets. So, our goal is to find out which one is accurately detecting and counting the people. So main objectives are to evaluate the performance of different YOLO versions in detecting the and counting the people, and to test and analyze the models on two dataset to assess the adaptability to the different crowd distributions and densities. And also we need to identify the most suitable YOLO model for applications such as event monitoring, safe and smart city surveillance. The methodology is, so we wanted to check how well the different versions of YOLO can be detected and count the people when they are spread out in the image. So the basic idea is simple, that we have to we have to take an image and fed into the YOLO model. The model has to find where the people are by drawing the bounding boxes around them. Then we are counting the algorithm. It will count the total number of people in the image. So in this way we can measure how good each YOLO version is at finding and counting the people in the sparse regions. This is the basic architecture of the YOLO model. Firstly, we will fed the image into the YOLO model. This YOLO model will extract the important features from the image, and then it will detect the people and draw the bounding boxes around them, and then we will use a counting algorithm to the model, and it will uh, give us the final predicted count. So these are the dataset details. In the first dataset we have 2400 total images. In that we have 2100 training images and 200 validation images and 100 testing images. And from dataset 2 we have 6480 total images and 5670 training images and 541 validation images and 269 testing images. So these are the results of two different data sets. From dataset 1, we have evaluated by using four different matrices, that is precision, recall, MAP 50 and MAP 95. And this is results of dataset 2 of five different models. And is the confusion matrix. From this confusion matrix, mainly we can differentiate the person and the background in the image. So these are confusion matrix from five different models, from YOLO V5, V7, V8, V9, V10 from dataset 1, and this is confusion matrix from dataset 2. So finally I have compared the different YOLO models from a sample image of dataset 1. From dataset 1 we have took a sample image with 14 people in it. So YOLO V5 have predicted 15 out of 14, and YOLO V7 has predicted 14 out of 14. So YOLO V8 has predicted 11 out of 14, and 9 has predicted 16 out of 14, and V11 has predicted 14 out of 14. So this is the results from dataset 2. From dataset 2 I have taken sample image which consists of only 18 people in it. The YOLO V5 has predicted 16 out of 18, and V7 has predicted 18 out of 18, and YOLO V8 has predicted 18 out of 18, and 9 has predicted only 14 out of 18, and V11 has predicted 18 out of 18. By this results, we can clearly see that YOLO V7 and V11 has predicted correctly, uh, even though with different data sets. So concluding, so my study mainly aims to see the performance of different versions of YOLO models by in detecting and counting the crowd, especially in the sparse regions. After conducting all these experiments, we can clearly see that YOLO V7 and V11 has outperformed the other models in detecting the crowds with higher precision and recall. So, however, these models will struggle in challenging different kinds of environments also, or in the different kinds of weather conditions also, like low light conditions and occlusions, even in the dense crowded areas as well. So in future, we can also integrate or we can combine this YOLO with transformer based networks as well to increase the detection purpose, especially in the sparse regions. These transformers can help us to focus on important details, making it easier to detect the people in the crowded areas. So this may increase the accuracy, especially in the poor lighting conditions as well, when people are especially occluded by each other. Thank you. This is all about my paper presentation. Thank you.
Okay. Nice
Thank,
presentation.
thank
Nice
you.
presentation, Vaishnavi.
Thank you.
One question: how reliable is YOLO in handling false alarms? For example, suppose detecting shadows or objects look like people in sparse region.
This YOLO is a well-known model, ma'am. For especially, it is a well-known for object detection because of its speed and accuracy. So it can, if you use a high computational power with high crowded areas, and also combining a latest versions, we can easily detect them.
Oh, fine.
Okay.
Thank you for the presentation, ma'am.
Thank you.
Moving on next, I'd like to call Mr. Hamad sir, Hussain sir for the paper titled Gamified Learning, a mobile app for supporting autism education and treatment in Libya. So please can you start with the presentation?
Is my screen visible?
Yes, sir.
Greetings, everyone. My name is Hamad Saleh, and I will present a gamified learning, a mobile app for supporting autism education and treatment in Libya. We'll start with introduction. Autism spectrum disorder, or ASD, is a neurodevelopmental condition characterized by challenging. It describes individual with a specific combination of impairments in social communication and repetitive behaviors. Early intervention is crucial for children with ASD. Psychosocial therapy such as behavioral and developmental developmental therapies can significantly improve key skills like joint attention, language, and social engagement. Technology is transforming healthcare and education, especially for ASD. Tech tools provide personalized, engaging ways to support learning and communication for these children. Libya faces significant barriers in adopting these tools for education and therapy. Limited infrastructure, lack of specialists training. And because of these limitations, many children with ASD miss out on tech-based interventions that could transform their learning and communications. This gap highlights an emergent need for investment and awareness. For the literature review, We searched in previous studies for apps used to educate and treat children with ASD because there's no use of these applications in Libya. The first application, called Math for Autism, is a specialized mobile application designed to help children with ASD master fundamental math concepts like numbers, shapes, and size. The other app created using Android Studio is specialized to improve speaking skill and language acquisition for these children. And two of these applications were developed and used in Malaysia. Our research concept to tackle Libya's critical shortage of autism resources, we have developed a mobile application designed to educate and treat children with ASD. This app is not just a tool, it's a bridge turning everyday device into interactive learning platform that address both academic and developmental needs. Our app uses game-based learning to teach and treat children with ASD using interactive games, because the games can get easily attention of the children's. Our objectives is developing a mobile application to educate and treat children with ASD, make the app easy to use with friendly user interface with icons and colors to get the attention of the children, and educate the children in different areas like math, language, and colors, and treat them with treat them in the social communication skills. Our applications developed using Flutter. It's Google's open source framework to power this application, because it's always it allows us to deliver a high performance, beautiful experience across all Android devices. And Flutter gives us the ability to easily expand to iOS in the future if needed. Our application features 5 games, each targeting a critical developmental area for the children with ASD. Together, they create a comprehensive learning environment that can improve academic and social skills, all through engaging therapeutic play. And these games are math, Arabic alphabet, matching shapes, social questions, and colors. And this is a screenshot of the application. On the left side is the game menus, and the 3 of the games, it's the math and matching shapes and the colors. To validate our app effectiveness, we conducted a 2-month case study with 10 children diagnosed with ASD at Al-Baida Autism Center in Al-Baida City. This real-world testing allowed us to observe how the app supported their educational and developmental progress in a controlled therapeutic setting. And the use case, 10 children, 8 males and 2 females, and each session is 15 to 20 minutes. Result obtained from using the application were classified into the 3 groups. The first group consists of 3 children who didn't benefit from using the application. These children have a significant problem in engaging with the app. And the app cannot get their attentions to do the games and the tasks of the applications. The second group consists of 3 children whose performance was stable during the observation of all sessions, and their performance was slightly progress. The third group consists of 2 children who has a good progress during using the app of all the missions and have improved in most of the games. Conclusion and the future work. Development and implementation of mobile application designed to treat and educate children with ASD in Libya present a significant step forward. The result highlights that the challenges faced by children with severe autism because they have a problem in attention and engagement with the app. In the future work, we can integrate AI-driven strategies into app for children with ASD can enhance personalization and engagement and effectiveness. And can we use we can use natural language processing to support language developmental development and make conversation games conversation games like the child and app can have a small conversation. And thank you for your attention. Any questions?
Okay, nice presentation. My question is the app designed to work offline given the connectivity challenges in some region of Libya?
Yeah, of course. The applications work offline, and they can download it from any city of Libya.
Okay, okay. And what are the specific educational and developmental challenges faced by autistic children in Libya? Any
Because
specific?
of the lack of training the specialists, they have a real problem in learning and learning the basic skills like math and social communications. We try to build this application to make them learn efficiently with the app.
Okay, fine. Thank you.
Thank you.
Thank you for the presentation, sir. Moving on next, I'd like to call Mr. Yash Suthar for the paper titled AI and Monkeypox, Revolutionizing Early Detection and Diagnosis. Sir, are you in the meeting? Okay. Next, I'd like to call Kartika ma'am for the paper titled A Bio-Inspired Framework for Lung Cancer Classification Using Fast Walsh, Transform and Gene Expression Data. Ma'am, can you please start with your presentation? Kartika ma'am, are you in the meet? Seems like ma'am is not in the meeting. Yeah. Kartika ma'am, can you start your presentation?
Yes, ma'am. 1 minute, ma'am. Am I audible, ma'am?
Yes. Ma'am, are you presenting?
Yes, ma'am. Actually,
Sorry?
is it visible, ma'am, my screen?
No. Okay, now
Yes.
it is visible.
Can I start, ma'am? Hi, all. My paper name is My Bio-Inspired Framework for Lung Cancer Classification using Fast Walsh, Hadamard Transform, and Gene Expression Data. So before starting my presentation, thank you for the opportunity to present my research work in this conference. And I would like to express my gratitude to my co-authors, Dr. R. Arikumar and Dr. Rajanar Nair, for their contribution. So these are the things I would like to present in my presentation. Dimensionality reduction techniques, need for feature selection techniques, classification methods, result and discussion, conclusion. So first of all, here lung cancer is one of the leading causes of death. So I'm depending on lung cancer, and I would like to classify lung cancer into two types. So we know that the early detection of lung cancer is very important for the effective treatment and higher chance of survival. The clinical and biopsy procedures for cancer tissues performed for cancer detection is a common method to identify the presence of cancer. But in this research work, I'm focusing on the microarray gene expression data analysis solves the problems which is faced by the conventional diagnosis methods. So the main advantage of using microarray analysis is it is non-invasive method. All other biopsy, all other clinical methods are actually invasive methods. That is the main advantage. So microarray analysis allows for early detection of changes in gene expression pattern. That is another main disadvantage of using microarray analysis for lung cancer classification. So these are some of the works that I have used for the previous works review purpose. And so the methodology that I'm using is, my aim is to enhance the performance of classifiers using dimensionality detection and feature selection methods for the early detection of lung cancer from microarray gene data expressions. So in this research work, I have used fast Walsh Hadamard transform for the dimensionality reduction and harmonic search and dragonfly algorithm as a feature selection methods. And the classifiers that I have used is Gaussian mixture model, naive Bayes classifier, random forest, decision tree, and SVM RBF. So this is the main methodology of this research work. First of all, I would take in one microarray gene expression data set for lung cancer. Then I have applied dimensionality reduction technique that I have used as FWHT that I have already mentioned. And in the first method, from after dimensional reduction, directly I have classified without applying feature selection methods. And after that, I have used some performance metrics to analyze the classification. After that, the same data which is applied dimensional reduction is given for feature selection techniques. Here, harmonic search, dragonfly optimization algorithms are used for feature selection. And again, I have given for classification purpose and analyzed the performance of classifiers. So without feature selection and with feature selection, I have applied classification. So the data set I have used is lung hardware 2 medical imaging data set, which is included large number of samples with high variability. In this data set, it is containing mainly two classes, adenocarcinoma and mesothelioma. So total of 12,533 genes are included in this data set. Within that, 150 of adenocarcinoma and 31 of mesothelioma cancer classes. So we know that the inclusion of more features are leading to the worst performance of classifiers. So the main advantage of using dimensionality reduction to increase the exponentially, it will reduce the dimensionality of the data set and thereby improving the accuracy of the classifiers. So here I have used fast Walsh Hadamard transform as a dimensionality reduction technique. So this is about fast Walsh Hadamard transform. It is actually Walsh Hadamard transform is transforming a signal into a basis of orthogonal Walsh function. It is actually using, it is represented by the multiplying the input data by Hadamard matrix. And this is actually the equation for using FWHT. And the size of Hadamard matrix is always the power of 2. So this is actually an average statistical analysis after applying the dimensional reduction. Here I have used the statistical features like mean, variance, QLS, kurtosis, PCC, and also CCA values for the analysis. So here from the table, we can analyze that the high average value of mesoclass indicating a slight shift in the central tendency of the data. And also actually variance is also high for meso, revealing that the data is more compared to the adeno data. And here the PCC values are quite close for both types. It is actually suggesting a similar linear relationship between the variables under the study of both cancer types, adeno as well as meso class. And a CCS score of 0.4906 actually suggesting a moderate relationship between the two sets of variables. So this is actually a scatter plot for FWHTDR. It is actually representing the classes are grouped and have a non-linear intersections, which is showing or indicating the non-Gaussian distribution. And it is also there is a presence of outliers among the two classes visible after applying the FWHTDR technique. And next, I'm moving to the feature selection techniques. Here I have used harmonic search and dragonfly optimization algorithm as feature selection techniques. Harmonic search and dragonfly actually bio-inspired techniques, algorithms. Here, harmonic search is actually techniques inspired by the process of improvisation and music. The generation of harmonies, musical notes represent the potential solutions. Here, the H is actually maintaining the memory of promising solutions called harmony memory, and it is actually maintaining harmony memory based on HMCR and PAR. So next time moving to dragonfly optimization, it is actually a community characterized with real insects, and the major characteristics is separation, alignment, and cohesion. Separation is represented based on the positions, and the alignment involves velocity and as well as the numbers. So this is about feature selection techniques. So after applying HS and dragonfly feature selection techniques, I have used Freiman test as well as box plot for analyzing the pattern of data. So here the chi-square statistics is low and p-value are not significant. That is above, it is about 0.01 value for HS feature selection. So it is actually indicating the consistent classifier performance across the models. But for DA, it is actually the lower p-value, almost near to 0.01. It is actually indicating the potentially significant difference in classifier performance, likely due to DA resulting in a under spread of results. And next is actually box plot. It is also representing or illustrating the spread of data. Here, HS feature selection plot shows a narrower interquartile range compared to DA. So that means HS yields a more consistent set of features for lung cancer classification. But for DA, it is actually a wider IQR, indicating greater variability in the selected features. So these are next is classifiers. I'm going to classifiers. This is the first classifier, GMM. So GMM is actually fitter distribution will be selected based on the Bayesian information criteria maximization. Next is naive Bayesian classifier, which is using probabilistic machine learning algorithm, which is derived from Bayes theorem. And this is decision tree and random forest. Both are actually almost similar, only the small differences are actually there. Both are depending upon the entropy measures or impurity measures. Information gain and entropy are achieved or using for splitting the data here in decision tree and random forest. And next, the final one is support vector machine classifier, which RBF. So it is actually mainly using for non-linearly separable data. These are some expressions for RBF. And next thing is actually training and testing of the classifiers. Here I have performed k-fold cross validation for training the model. And this is actually confusion matrix, TP and TN for adenocarcinoma as well as mesocancer. And I have used for the training purpose MSE as MSE value for training the purpose. And this is about training and testing MSE of the classifiers for dimensional reduction techniques without and with feature selection techniques. So here actually SVM RBF is showing a better lower training and testing MSP for without feature selection, and this is for feature selection with feature selection. And here in all the without feature selection as well as with feature selection, SPM RBF is showing lesser training and testing MSE compared to other classifiers. So this is actually for evaluation of FTWHT DR techniques without feature selection. Actually, I have used accuracy, FN score, MCC, GDR, and kappa as a performance metrics of for analyzing the classifiers. So this is actually without feature selection. Here SPM RBF is showing better accuracy, which is compared to the other classifiers. And this is for the methods with harmonic search feature selection. Here also actually SPM RBF is showing 89.50% of accuracy compared to others. And here in both without feature selection with HS feature selection, actually RF random forest is showing lowest accuracy compared to other classifiers. But when it is reaching to the evaluation techniques of after applying dragonfly optimization, random forest is showing the better accuracy compared to all other classifiers. And this is actually the better accuracy I got in the complete research, where it is 90.05%. So next I'm going to my conclusion. So as I told that when it is discussed about lung cancer classification in any other classification, the early detection is very important to extend the patient's life expectancy. So this work utilizes microarray gene expression incorporated with machine learning techniques to attain high accuracy with a minimum error rate. So in the whole research work, RF classifier reported a maximum accuracy of 90.05% when using dragonfly optimization feature selection, along with a notable GDR value of 89.15. And next, whenever discussing about the future work, I would like to incorporate deep learning methods or long LSTM methods for better prediction and analysis. And these are some reference works. And finally, thank you for listening me.
Okay. Wonderful presentation, madam.
Thank you, ma'am.
Okay. What is the biological inspiration behind the dragonfly algorithm?
It is actually the methods of insects, dragonflies, the separation, alignment, cohesion. These are some methods characterized in dragonflies. So that is the inspiration of dragonfly optimization algorithm.
Okay. Thank you so much.
Thank you, ma'am. Thank you so much.
Yes.
Thank you for the presentation, ma'am.
Thank you, ma'am.
I sincerely thank all our authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th version and all the previous 8 versions of this conference. We'll be happy to have you all in the 10th version in 2026. So all the presenters would be getting their digital certificates via mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. This is a token of appreciation. This is a token of appreciation to the session chair on behalf of the team ICTIS 2025 and Global Knowledge Research Foundation and partners. Thank you, ma'am, for your valuable presence.
Thank you so much, ma'am.
Thank you, ma'am. So before we end, I want everyone to take a quick, switch on your cameras for a quick snapshot. One of our participants has come late right now. Yash sir, I guess, and they're willing to present the paper. So can you just wait for 5 minutes and take the presentation? Sir, can you please present your presentation? Hello.
Yes, ma'am.
Yeah.
Yes, ma'am. It is visible. Hello.
Yes, so you can start.
Good afternoon, everyone. So first of all, sorry to late to come. Good morning. I am Yasutha from Parul Institute of Engineering Technology, Parul University, India. Today, I will be presenting our research on artificial intelligence and monkeypox, revolutionizing early detection and diagnostic. This study was conducted in collaboration with my co-authors, Chintan Thakur and Amit Vajpayee. We are grateful to for this opportunity to present at ICTIS Thailand 25. So, to give you a roadmap of this session, we will be beginning with an abstract of our research, followed by our introduction to monkeypox and the role of AI in medical diagnostic. We will walk through the literature survey, identify research gaps, then share our process methodology and future work. Finally, we are conclude with the key findings and references. In abstract, monkeypox has re-emerged as a global health threat, spreading beyond the traditional academic regions, while PCR remaining the diagnostic standard is so costly and inaccessible in raw research settings. Our research explore how deep learning can serve as a fast, scalable diagnostic alternative, particularly through the screen lesson event analysis. However, challenges like dataset diversity, model interpretability, and computational cost persist. Nevertheless, we found that AI can significantly aid early detection. In introduction, monkeypox is a zoonotic disease from the orthopox virus genus, the same family as smallpox. First discovered in monkeys in 1958. The first human case was reported in 1970. Early diagnosis is critical in controlling the spread. The visual here, either a timeline or a world map, can show the geographical spread and increase to outbreak frequency over time. This presents an opportunity for artificial intelligence, spreading deep learning to automate diagnostic using skin lasers image. Deep learning offers speed, scalability, and potential for integration into mobile and low-cost platform. Here is a literature survey. The first year is the 23 and the author name is H.F. Ellison. Use a mobile weight-based mobile application for monkeypox detection using achieving 95% accuracy. And the second one is Ram Guru in 2023 highlighted the lack of comprehensive diagnostic tools, and 23 Nayak and Sampathila utilized ResNet 18 achieving 95.49 accuracy. In 2022, author C. Situla and C.B. Sai compare 30 pretend models and achieve 87.13 accuracy using assemble methods, but binary clarification limited their performance. In 23, use inspection ResNet version 2 and NestNet large for feature fusion, achieving 95.59 accuracy. Yet feature extraction of low contrast images remain problematic. So research gap is dataset limitations and intervality, computational cost, and clinical validation. Current datasets are small and lack diversity, affecting generalization. And deep learning models operate as black boxes and making clinicals hesitant to trust them. So high-end GPU are often required, limiting using rural and resource-poor settings. So most studies are based on pre-computed datasets and limited real-world testings. So our proposed work, leveraging combinations of CNN, DNS transformer, and hybrid architectures, encrypting attention mechanism for greater interpretability, using adversarial training to enhance robustness, solving data security and augmented and synthetic data generation, optimizing model for low resource deployment, mobile net V2 and tiny ML are prime candidates. So in conclusion, deep learning models are transforming monkeypox diagnosis with some models achieving over 95 plus accuracy. CNNs and DNSNet and hybrid models show great promises in real-time lesion classifications. However, challenges remaining data scarcity, modern instability, and cost barriers. These are actively being addressed through the advanced architecture and open data efforts. So future directions are expanding data set with real and synthetic images, developing multimodal diagnosing that combine images with clinical inputs, mobile-friendly optimization through tiny ML and model tuning. One critical concern in clinical AI is trust. Doctor want to know why the AI made a prediction. Explanation AI tools like GridCam will help visualize which part of an image influence the model. The bridges the gap between AI output and medical decision making supports global development for early detection and outbreak surveillance. Uh, uh, for references, this reference reflects the foundations work that guide our research. We study brought critical insights into model performance limitations and innovation potential. Thank you all for your attention. AI-driven monkeypox detection was great promise, not just as a technical challenge, but as a real solution to global health crisis. I am happy to take any questions you may have.
Okay. A nice presentation, Yash.
Thank you, ma'am.
I just wanted to know one thing. What is the current global status of monkeypox outbreaks in
Current
India?
monkeypox in India, there are
Global.
globally it is mostly having Asian countries and in Pacific countries. There are many cases are there above 1500 plus cases. In India, there are 2 cases in Kerala for monkeypox.
In 2025?
Yes, in 24, ma'am. Sorry,
In
in 24. Yes.
Okay. Okay. Thanks. Okay.
Thank you, ma'am.
Right.
Thank you, sir, for the presentation. And thank you, everyone. Sorry for taking this last presentation again. Have a nice day, everyone. You all can leave. Thank you. Have a nice day.